Hello there, CP Finite, and welcome to lesson 1.1, okay? So generally, our lessons here with our notes, since this is one of our first stints of notes, is if you have the problems written down ahead of time, that's great. If you have your calculator ready, that's awesome. And I try and be as straightforward and go rather quickly, but also thoroughly. So, central question, how do you write the equation of a line, and how do you graph a line? Hopefully most of this stuff is review. To begin here, we're going to be looking at two different types of equations. This is going to be the slope-intercept form. So slope-intercept, that's in the form y equals mx plus b. Do you remember all that? And there's also standard form. We'll look at both of these. Standard form, that is ax plus by equals c. Two things about a, it cannot be negatives, so no negative, and it cannot be a fraction, and not a fraction. Two things for that there. All right, so let's look at a first example here. So first way is if I want to write a slope-intercept form, and this is kind of scenario one. Maybe I'll give you a point and a y-intercept, okay? If you're given a point and a y-intercept, that's pretty easy. The y-intercepts are always going to have the form 0 and some number. We'll call that b. Well, from slope-intercept form, we know that's y equals mx plus b. It's pretty easy. I'm just going to, m is our slope, so I'm just going to plug that in. And b is our y-intercept, so I'm just going to put that in there. We got y equals 2/3 x and minus 3. All right, so that's standard form. That's slope-intercept form. If I wanted to write that to standard form, okay, it's not too hard to do. We just want to get the a and the x and the by on one side and the constant on the other. So to write this in standard form, really we're going to subtract the 2/3 x from the other side. So we'd have negative 2/3 x and plus y, and that's going to equal negative 3. And for standard form, we just have to fix it up here. So we don't want a negative, and we don't want a fraction. So if we multiply each side by a negative, and also by the greatest common denominator, 3, so if I multiply everything by negative 3, that will get rid of the fraction and also the negative. So that'll make it 2x minus 3y equals 9. Okay, so be careful distributing. This is the standard form equation, and this is the slope-intercept form. So you should be comfortable in both. They have different ways that they can be useful in the future. Okay, next type is point slope. So if this time I'm giving you a slope and just some necessary point, it's not necessarily the y-intercept, it's just any old point. For this, we need an old tool, y minus y1 equals mx minus x1. That should be a little reminiscent from your Algebra 2 days. For this, y1 and x1, if you remember, those are the coordinate points, x1 and y1. Okay, and basically you're just substituting things in again. So y minus y1, which is 5, equals m, which is negative 3/5, times x minus x1, and parentheses there. Now be careful, this is a negative 2, so it's minus a negative 2. That's why I put the double parentheses. And then we're basically going to be solving for y. So y minus 5 is equal to negative 3/5 x. This is originally a positive 2, and I'm going to distribute a negative 3/5, so it's going to become negative 6/5. Calculators, so in this course you should be relatively comfortable with dealing with fractions. That's what your graphing calculators are for, and generally always write them in fractions, negative 6/5. So we're almost to standard form or slope-intercept form if we add 5 over. So again, my calculator can help me with that. Y is equal to negative 3/5 x and then plus 19/5. Okay, so that's slope-intercept form. Let's also practice writing in standard form. So if I add 3/5 to the other side, and I just have plus y equals 19/5. All I need to do then is multiply by the greatest divisor, or the greatest denominator, and multiply everything by 5. Therefore, 3x plus 5y equals 19. So standard form, slope-intercept form. Your textbook will probably ask you to write them in both, so it's good to, again, know them both. 2-point form. This one involves the most amount of work here. This time, we're going to need another new formula, old formula really, and that's to find slope. So if we have m equals y2 minus y1 all over x2 minus x1, that's the old way to find slope. I also recommend labeling our points here. It doesn't quite matter as long as x and y. And that's just going to help you plug things in. So students typically mix up y's and x's, so we're just going to make sure we get them right. So negative 5 minus negative 3. You can get tricky with the negatives, so take your time. 2 minus 1. Negative 5 minus negative 3 is negative 5 plus 3, which is negative 2. 2 minus 1 is 1 over 1. So really our slope is negative 2. All that for the slope. Once we have the slope, then we can utilize the strategy above and use point slope form. So now I'll take, and you can choose either point. I'm going to choose this point here. Why not? So y minus negative 5 equals our slope, which is negative 2, quantity x minus 2, and we'll go from there. So y plus 5 is equal to negative 2x plus 4, and for slope-intercept, that means y is equal to negative 2x minus 1. And if I wanted to write it in standard form, hey, that's pretty easy. I'm just going to add the 2x over 2x plus y equals negative 1, and one's taken care of. Boom, boom, boom. There's standard and slope-intercept. Standard and slope-intercept. Some common questions. Y does not have to be negative. Just the a value cannot be negative and anything like that. Now, a little more challenging one is one with fractions. Don't let them scare you. It'll be okay. Let your calculator do the hard work. So this particular example, x1 and y1 and x2 and y2, we're just going to be careful. So 2 minus 3 all over. x2 is negative 5 halves and minus 1 half. This is also why your calculator can be helpful, okay? Fractions are not a problem for it as long as you type it in there, okay? Now, let's take care of the numerator first. So 2 minus 3 is negative 1. Then let's take care of the denominator. I would recommend, if you're going to use your calculator, always use the parentheses around fractions. Always parenthesize. I don't think that's a proper word, but we'll use it here. Now, you might already know you have same denominators, so you could subtract, but sometimes students get scared of fractions. So it's really just 1/3. Okay, that's the slope. Next is, okay, we found the slope. Let's pick either point. I don't know which one's nicer. We'll just pick the first one. So y minus 3 equals 1/3 x minus 1 half, and distribute minus 1/6 equals y minus 3. And we'll add 3 to each side using the calculator. So negative 1/6, okay, plus 3. And we'll write that as a fraction again. So 17/6. Y equals 1/3 x plus 17/6. There is our slope-intercept. Let's write it in standard form. So I'm going to add or subtract the 1/3 over plus y equals 17/6. Now, got to fix it. It's a negative, and I need to get rid of the fraction. Now, we're going to multiply by the biggest denominator we see, so I'm going to multiply everything by 6, actually, a negative 6. And that'll get rid of all the fractions, which is going to be nice. So negative 6 times negative 1/3 is going to be 2 minus 6y, and then equals negative 17. So that is proper standard form, and above here was slope-intercept form. So hopefully you're getting the hang of those now. Last 4 types of lines are vertical lines, horizontal lines, and really this stuff's real easy, but they're commonly mixed up, so be careful. A vertical line always has the form x equals some number a. So horizontal is y equals some number a. Okay. If we want a vertical line to go right through this point, if we kind of look at it on a graph, this is an ugly graph, but that's okay. 3, negative 2 would be about over 3, and we'll say about there. Okay. That is a point 3, negative 2. So I want a vertical line to go through there, which would be right through here. Well, the x-coordinate there is 3. So this vertical line is going to be x equals 3. Vertical is always going to go through the x-coordinate, whereas the horizontal is always going to go through the y-coordinate. Notice it's the same points, y equals negative 2. So note to self, horizontal is always y. Horizontal is y, and vertical is x. Alrighty. The last part of today. I know a little longer notes, but hey, you guys can take it. You can always take a break and pause and come back. Graphing a line, okay? So let's look at graphing. It's pretty easy stuff, all right? And hopefully, again, most of this stuff's review. If you're in SlopeIntercept, it's pretty nice because right there we got our slope, and right there we got our y-intercept. Now the y-intercept is always on the y-axis, and there's a big old y for this axis. So you're going to start at 2. That's where we start. And the slope, if you remember, that is rise over run. Rise over run. So really you can think of it as 3 over 1, and we'll go up 3, boop, 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 over 1, up 3, over 1. And you can do your best to connect the dots. I have a nice little connecting thing here, which is kind of cheating on my end, but hey, it looks nice. B, same idea, just careful, it's at negative 2. Now we have a negative slope. So this one you're going to go down and then to the right. You could also go up and to the left. It doesn't really matter, but make sure it's going downwards. So down 3, 1, 2, 3, over 5, 1, 2, 3, 4, 5. Likewise, 1, 2, 3, 1, 2, 3, 4, 5. Students always mix up negative slopes, and it's just they're going down. That's all. Going downhill. Do-do. And do-do. Perfecto. Alrighty, so letter C here. This one is in standard form. So there's 2 different ways to graph this. I'm going to show you the table method. So we can actually find the intercepts. Find intercepts. And to do that, I make a little XY chart. So X and Y, 0, 0. What this chart will tell me to do is to find the x-intercept. Okay, we'll actually plug in 0 for y to find the y-intercept, 0 for x. But really, all you're doing is substituting 0 in for x. So it's 4 times 0, which is 0, minus 3y equals 12, and dividing by -3, I know I'm overwriting stuff there, means that this is -4. So I have the point 0, -4. 0, 1, 2, 3, 4. That's on the y, Mr. Dvorsky. So it should be there. Sorry. Second pink dot. The other point is going to be 0 in for y. So it's 4x minus 3 times 0 equals 12. We write that here. And that means 4x equals 12. And divided by 4, x equals 3. So 3 on the x-axis. And we're going to connect those. Boo, boo. It's pretty good. Now, I fixed my little mistake earlier, but be careful with those x and y's plotting those. Y equals 4. So if you just have that, that's simply a horizontal line through the y-axis at 4. So horizontal line, y-axis, 1, 2, 3, 4. Going to go right through here. It's our yellow one. Vertical line at -3. So remember that's going to be vertical. And -3. 1, 2, 3. And up and down. Ooh. Through all those. All righty. Deep breath. We're going to finish up graphing some applications. They can be a little trickier because they can get into big or small numbers. What I always recommend is first for applications, find the intercepts. So let's find the intercepts for these. That's going to tell us how big or small to make our graphs. So that is where we're going to use our little trick, x, y, 0, 0. So for 0 in for x, it's just going to be 1,300 times 0 plus 390. Y equals 39,000. And basically, you're just going to divide 39,000 divided by 390. And you might already know that in your head. But if you don't, that's okay. 390. Oh, how about that? A nice 100. Likewise, substitute 0 in for y. 1,300x plus 390 times 0 equals 39,000. And essentially dividing that by 1,300 gives you 30. Okay, so looking at it, you can't quite tell that on the y-axis. So what this means is my y-axis, I need to go at least up to 100. Okay, so you can choose how to divvy these things up. I won't be too picky with that, but you should be comfortable doing this. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So if that's 100, it's right there. And 30, try and take up as much space as you can. So mostly we'll say every 4 is actually 10. So it's kind of like 20, 40, 60, well, not 20, 40. 2, 4, 6, 8, 10. We'll go a little bigger there. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Okay. Just make it the same. Try and use up as much as you can. I know I went back and forth, but you get the idea. Okay. And lastly, with decimals, kind of the same idea. Just use the table, find the intercepts, and I won't be overly picky, but sometimes your textbook has examples with funky numbers. So don't be afraid of them. I'll always help you out with rounding and stuff as far as points goes. But let's find the x and y. So 0 in for x. You can almost imagine just we're going to be dividing 260 by 1.3. So it's 200. And 0 in for y, we can imagine 260 divided by 2.5. And we get 104. So that's a little funky there. So on the y-axis, up to 200. I think if we go by tens, we'll still be okay. 10, 20, 30, 40, 50, 60, 70, 90, 100. 10, 20, 30, 40, 50, 60, 70, 80, 90, 200. And on the x-axis, so we'll still go by tens. 10. And since it's 104, again, I won't take off points as long as it's close if it comes to quizzes and tests. But be generally comfortable with doing those things, okay? So great job, guys. I know it's a longer stint of notes. They won't always be this long. But feel free, again, always pause and make sure you look at Schoology as to what the homework assignments are. And please practice them. You all rock, guys. Have a good rest of the day.